Hi everyone, I'm Dr. Subbarao from RVIT Institute of Technology. In this video, I'm going to explain properties of carbon nanotubes and applications of carbon nanotubes. The first one, these are mainly categorized as mechanical properties, electrical properties, thermal properties and other properties. So the first one is the mechanical properties. First one is the high tensile strength. Carbon nanotubes are incredibly strong with a tensile strength up to 100 times greater than that of the steel. That means these are having the high tensile strength. Next one, high elasticity. Elasticity means when we applied an external force, then the material elongated with respect to the force. After removing the external force, the material regained its original shape and properties. This property is called the elastic property. Here, these are very elastic and can withstand a significant deformation without breaking. That means the formed carbon nanotubes are highly elastic. They can elongated with respect to the force, and they will never change their properties after deformation also. And the next one, high Young's modulus. This is the Young's modulus is the parameter of the materials, indication of the stiffness and weakness. If the Young's modulus is high, which indication of the materials are hard and strong. If the Young's modulus is very low, which indicates the materials are very weak and porous materials. So according to the carbon nanotubes, here the carbon nanotubes are having the high Young's modulus, which means they are hard and tough materials. And the next one, low density. When compared to the steel, carbon nanotubes are having significantly lower density. Means the density is very low when compared to the steel. Steel means iron. And making them attractive for the weight sensitive applications. That means we can fabricate the materials with lightweight. So lightweight materials can be fabricated by using the carbon nanotubes. And next one, buckling. Buckling means when we applied the pressure, the materials can be bent or maybe twisted or maybe elongated. So this properties is called the buckling property. While strong in tension, the carbon nanotubes can be subjected to the buckling under compressive, torsional or bending stress due to their halo structure and high aspect ratio. So due to the carbon nanotubes are having the halo structures and having the high aspect ratio. That means its length is much greater than that of the diameter. So the length is more than the diameter. And here these can strong tension. These are having the strong tension. Why? Because of the halo structures. Next, coming to the electrical properties. The first one is electrical conductivity. So carbon nanotubes may be metallic in nature or maybe in semiconducting nature. This will be depending upon the particles and the structure of the carbon nanotubes. So by depending upon when the carbon nanotubes are having the metallic nature, that means they will conduct electricity and they are acting the good conductors of electricity. And if they are having the semiconducting nature, they partially conduct the electricity. This is all depends upon the nature of the carbon nanotubes. And the next one is the high current carrying capacity. All the carbon nanotubes are extremely high current carriers. That means they can withstand at a high current densities. Next one, field emission. Carbon nanotubes are excellent electron field emitters and making them useful in applications like field emission displays. So these are used in physics dynamics. So why? Because of they are acting as excellent field emitters. That's why we are using the more application oriented dynamics. And next one is the thermal properties. So high thermal conductivity. Carbon nanotubes are excellent thermal conductors with some structures exhibiting the thermal conductivities revealing those of diamonds. That means they can withstand at high temperatures also. And they have low thermal expansion. That means when we applied the heat, they will have the low expansion or low compression, which means it will not react much more when compared to the other materials. So they have low coefficient of thermal expansion, which means they don't expand or contract more much with the temperature changes. So this is the low thermal expansion. And next one, thermal stability. They are highly stable when increasing the temperature or decreasing the temperature, which indicates the stability of the carbon nanotubes. So these carbon nanotubes can withstand up to 2800 degrees centigrade temperature in vacuum. And coming to the other important properties, high aspect ratio. That means the length of carbon nanotubes is much greater than its diameter, which contributes to their unique properties. That means the diameter will never change and the length of the carbon nanotubes, even they having the more length, the diameter will be same, which gives the unique properties to the material. And next one is the chemical inertness. Carbon nanotubes were inert in nature. That means they will never react with the other chemicals and they will resist the formation of corrosion. Next one is the flexibility. Carbon nanotubes can be bent and flexed without breaking. So they have the more flexible in nature. And large surface area. Their large surface area makes them suitable for the applications like catalysis and filtration. So they have the large surface area. So these are the properties of carbon nanotubes. Now coming to the applications of carbon nanotubes. I am showing here the general applications of carbon nanotubes. Here the carbon nanotubes widely used in energy storage devices. For example, batteries, capacitors. So these are also having the carbon nanotubes. And these are widely used for the fabrication of electronic displays of various electronic devices. Almost all the electronic devices having the carbon nano materials. And the next one, these carbon nano materials were used for fabrication of household materials and industrial materials due to lightweight and having the high mechanical properties. And these widely used in agricultural materials. So these are used for the making of nano biosensors. And these are used for making the nano tools like screws, nails, bends. And these are used for the in biology, surgical materials. So next, these carbon nanotubes are widely used in drug delivery system. That means these are used for the treatment of various diseases. This is about the some applications of carbon nanotubes. Now coming to the biomedicine applications of carbon nanotubes. How these carbon nanotubes are used in medicine. First one is the tissue generation. Carbon nanotubes are used for the tissue generation and as components of implants. All type of implants we are using the carbon nano materials. And next one, infection therapy and used as an antioxidants. These are having the antioxidant properties. That's why we are using the antioxidants. And next one, neurodegenerative diseases. That means CNS depressants are stimulants. For this purpose, we are using the carbon nanotubes. So these are used for biosensor vehicles for diagnosis. And also these are used in cancer therapy and gene therapy. These are the biomedicine applications of carbon nanotubes. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.